What is up, boys and girls? It's your boy Jade, aka the Shirtless Coder. So let's just go straight into recapping what we did last episode. Well, we attempted to go on to step 2, but we ran into a little area for refactoring. So this is why this episode is kind of part 2 of episode 2. So let's step into the code of what we did last episode. So previously, I had created a struct of my repo. This was as opposed to what I did in the first episode, which was just have a bunch of create file methods and some function. I thought it would be better to bundle up all of the information into a repo. That way I can manage it and its state throughout the file. So let's take a look at what this repo struct actually contains. It has some methods. Right now they're not being used. It just has all the index, the reference stuff. I can add in a bit of other stuff. And while this might not be necessary, I have a repo trait that just has an init function. And this just returns self. So here, I just create a bunch of the files. Now, if you remember correctly, this used to be in just the handle init function, but instead I have it just here. I just have init and I have a bunch of maps for errors. Additionally, we took the same strategy and created an index directory. Now, for those of you who don't know, the index file and the information can actually be found within Git's documentation. And I began working on that a bit in the previous episodes. So just for information, it has a 12-byte header consisting of DIRC, a 4-byte version number, and for now we're just going to stick with 2 just for simplicity, and the number of index entries. In today's episode, we're actually going to dive into creating this index entry. I think I maybe thought it was a bit more complicated last time, so I kind of stopped, but I realized like a lot of this information I can easily look up. In fact, when it's referring to stat2 data, here's the man page in regards to it. So for instance, this dev part is referring to dev right here, which is the ID of the device containing the file. So bear with me. Right now in this init, we're just writing the content. We're creating the file. This way, within our repository, it actually contains the index file, which you can see here, and it'll initialize it with the particular version. Now, what we need to work on at the moment is an index entry. And so, like I mentioned before, we could find this information within this man page and also the documentation. So let's just start writing some parts of this out. So we have the C time and seconds. C time seconds. And this is like just a U32. And we're going to comment some of this stuff. This is last time a file's metadata changed. We also have C time nanoseconds, which we'll just do like in S, U32. This is nanoseconds, okay? Now we have the M time seconds, U32, and this is going to be the last time a file's data changed. And now we have the M time nanoseconds, U32 nanoseconds. We have the dev, which was the device ID. Device ID. Well, I'm going to put like this for information. And I'm realizing that a lot of these need commas. Don't know why that automatically didn't put that there. Okay, we're gonna have the inno, which right now I'm just gonna put like which is a file serial number. File serial number stat2. We have the mode split into high and low bytes. So what I'm going to do is actually take this and create another struct, derive debug, and we'll do pub struct index entry mode, which will be high, which is U32, and low, which is U32. And then this will be a index entry mode. The object type, high and low, and ever multiple fields. Okay, the object type, which is going to be binary, symbolic link, and get link, and we're going to end up creating a struct for that as well. So we'll do derive debug pub struct index entry object type. Oh, sorry, this is enum. Now we will have binary. We'll have symbolic, and we'll have get link. Okay. So we'll have object type, which will be, index entry object type. We'll have unused. We don't actually need to create this in the struct. This will come later when we are trying to just write to the file. We'll have 3 bits unused. We'll have permissions, which I will skip for now, and we'll do that a bit later. UUID, so let's do that. UID, sorry, U32. And we can go again to this, and we have UID, user ID of the file. User ID of the file. And again, we're just documenting so that people understand what this is. We have the GID U32, and we'll go back to here. The GID is the group ID of the file. Group ID of the file, stat2. The file size, okay. File size. And this is the on-disk size, truncated to 32 bits. Okay. So that's good to know. On-disk size, stat2. Okay. Okay, so I am making a few adjustments as I go along, so this is going to be pretty long. So first of all, let's actually go ahead and change these names just to reflect what they're referring to. So this should actually be like regular file. This can be like symbolic. I think that should be the same. And then this is get link, I think is fine. Anyways, it doesn't really matter. And something I noticed on here earlier was I need to use SHA-1 for the object name itself. So I was thinking of just storing the name as is, as just a string, but it's actually the SHA-1, so we will need to take care of that. Additionally, I think the mode is a bit more complicated, where it doesn't seem to be purely just the mode from stat2 data. So if we check here, does it actually show? Yeah. I think that it would have normally said something in relation to, stat2 if it specifically was that. So that is something also that I have been getting wrong and had to remove when trying to do this. So some suggestions that I saw, and we can look at Stack Overflow as well as a few other sites, such as, I think I was looking at this site. So you can see here the object ID. So just to give some recap of SHA-1, it's 120 bit hash. And so if we do just 160, divided by 8, that's 20. So the way that we're going to actually handle this is we're going to do object name, which will be a U8 and 20 here. And this will be, let's see, this will be SHA-1 of objects. This might need to be actually, this. So we'll compute the SHA-1 of the object. Next, what we're going to need is we're actually going to 16-bit flags. So this will just be flags, which will be U16. Oops. Which I don't really need anything. Comments for that. A 2-bit stage. So this is the part that I'm not sure I fully understand. If the flag part, this is part of the flag, I'm not sure. 2-bit stage. And this is why it's like a little bit hard to understand exactly. And we have the file path here, and we can just do that here. So we can just do like file path, which can be a path buffer here. Okay, so right now we need to actually have some type of constructor, or just in general a way to construct this. And we actually can just use kind of an idiomatic way to construct this. But there's one caveat, and that we are on a Linux platform, and certain traits and information about the file is only available on Linux versus Windows. So just it'll make more sense as I get into this, but for right now we need this CFG flag specifically for Unix. And we won't be getting into the Windows side of it, just because I think it might get a little bit more complicated, but just note that that is something there. So we'll use the from trait, and we'll do like path here for index entry. And we will have from here, which I'll take this as path. And inside here, we're just going to use standard OS Unix fs metadata ext, because we're actually able to get a lot of information from here. So, for instance, let's take let metadata equal path dot, I think it's metadata dot expect. We'll just do fail to get path metadata. Okay. And I'm surprised that this is not just a because we don't actually need this part. Now, for a lot of this information, like this, we can actually get it from the metadata from this particular trait. So sorry, give me just a sec. Let ctime metadata dot ctime as u32. Let ctime nano, which equal metadata dot ctime. I think there's nanoseconds as u32. Let m time equal metadata dot m time as u32. Let m time nano equals metadata dot m time nanoseconds as u32. And yeah, there probably is data loss, but I think this is just the standard way of doing this. Dev and ino. So let dev equals metadata dot dev as u32. Let ino equals metadata dot ino as u32. Now we have the UID as u32. I believe that that's correct, right? GID GID equals metadata dot GID. That's already this. So let me see. Is this u32 already? And this is u64. Okay, so we have a lot of this information. We have well, we have the file path already. The file size. Let file size equals metadata dot size as u32. I do believe that it said it was truncated, so I think that is okay. So also a small issue here is that if I use metadata, apparently this will actually follow the symlink, if it is a symlink, to the desired file, which is not actually what we want to do. So I actually need to do, I think, like fs this, because as you can see, it actually doesn't follow the symlinks. So we need to use this instead. So, oops, I don't know what that is. We pass in here and we'll do expect fail to get path metadata this. So this is better. Okay, so something that I am reading here and I'm a bit confused about, so I could be wrong, but as you can see here, it's saying that the mode bits are actually split into different parts. So there's part A here, which is kind of the object type, which we saw here. We have object type, which is just like 4 bits. So 1000, 1010, and 1110. And then there's unused, and then the 9-bit Unix part. It's kind of unclear to me if this is all of this, I don't know, because like 4 bits, 4, 5, 6, 7, plus 9, it's a bit confusing because this is suggesting that, you see here, this is like only 16 bits. So why is it saying it's 32 bits? And that's what I don't understand. 1, 2, 3, or 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 bits there. So I'm not sure, because also then right here, it's saying 32-bit mode, which is the hexadecimal representation of the file permission here. This. So the part of this is just like 0, a bunch of zeros. And maybe that's what it's supposed to be? I'm not entirely sure, because that's a bit confusing. Because if that's the case, then I personally only need, then I don't need this mode part. I just need the object type, and I need like permissions. And in fact, I don't even think I need that because, well, maybe, I'm not entirely sure. Because if you can see here, it only has a couple of permissions that are valid. This and this. So I think, let me check this, because one of these might be executable. I think this is an executable file. Oh, it has full, yeah, executes. And then the other one is this. This read and write. So these are the main ones that are valid, and the symbolic links are 0 for this. So I need a way to basically just get like these permissions. Okay, so I actually thought of a better way of doing this. So I think what I can do is actually end up creating a permissions thing and just having the regular file contain the permissions, and symbolic and get link doesn't need that. So I can just do pub enum index entry permissions, and this will just be perm 644 and then perm 755. And the reason why I'm kind of representing things within objects and then trying to convert them into like the appropriate data, because it's easier to manipulate like the structs and enums and stuff, and serialize from into that. So if we do index entry permissions here, and then we'll actually put this up here, and we will do partially equal and equal here. And I think we need hash as well. Something that we can do, impl index entry, we have function mode self, and this is kind of, I think I end up liking this a lot more than what I was planning to do. So we can do self.object type, and if the index entry regular file perms, then what we'll do is we will let the object bits equal 0. And we are driving this because we know from the thing it says that the object type 1000 for regular files, so that's what we have here. And then we'll have the other stuff, but we need the 3 bits unused as well. So this is at the beginning, and then we have unused bits. Well, we'll do as U32. Actually, maybe we can do it here, U32. Just make sure that this is here. And we'll do U32, which will equal 1, 2, 3, 9. And then we will have let perm bits equals match perm. Okay, oops, perm. And we have index entry permissions. We have this, and we will do, actually, what is 644? And then index entry permissions 755 755. And then what we will do is we will return object bits, this unused bits, and perm bits. Now, if the other one, what we're going to end up doing, index entry object type symbolic, oops, this part here, we are going to, sometimes this is why I cannot find perm in here. Perms, okay. This is going to equal 0 be 1010, which we saw that, and then, bro, this is actually really annoying. Okay, and then we'll do this. And we'll do get link, and this will be 1110. Okay. So now we have the mode based on this. We'll need to calculate the actual object type. We'll do CFG Unix, and we'll do pub function compute object type, and we'll do path meta, yes, meta here, and we'll do index entry object type if meta dot file type dot is symlink, then we're going to return index symbolic. Else if meta dot is file, then we're going to get let terms will equal meta dot mode, and we're going to get part of the lower bits, lower 9 bits. Okay, now we're going to do let get perm equals match. Oh, I hate how it has this here. Match perms. I'm going to do 00644, and this will be perm. Wait, no. And this is annoying, but whatever. This. We'll do 00755. Permissions this. And I think we need like something else. Although this is probably not good. Permissions. We'll do this. Okay. Now we're going to do that. and we'll do index regular file, and the permission will be get perm. Okay. If maybe else clause. Okay. Now we do else if meta.is directory. Let get directory. Oh no, rget directory will equal path.join. We'll do rget. If rget directory exists, then we're going to index object type get link. And I don't think this is like good enough, but for now, I'm not personally sure how to do anything better. I think otherwise, we're going to treat it as a file. And I think the permission is just, well, it can't be the other one. So we're just going to do this. Otherwise, I think we just do this as the fallback. Okay. This might not be the best, but let's just do that. Let object type equals compute object type path and metadata. Oh, something else I think that's pretty important is to have the stage. So you can kind of see here, which I think we can represent as an enum. So slot 0 is, okay, normal unconflicted. Slot 1 is base, ours, and theirs, which I wish they told us more about this. Yeah, I think this is, yeah, mainly for merge conflicts. So I think let's go based on this information here and create an enum for the stage as well. I think we'll just do this, pub enum index entry stage. I guess we'll do normal, which is kind of the default. We'll do base, ours, and theirs. And we'll do impl default for index and index entry stage, and function default. I think it'll just be index entry stage is just going to be normal. Okay. So I think if we do it from here, we'll just use the default because I don't actually know what it should be. I think we could do like stage, index, entry, stage, there. Yeah. And then we'll do stage here. Let stage equals index entry stage default. Okay, I think we can do that. Okay, so we have all of that. We need to compute this and the flags. So let me go back to here and figure out how to compute the flags. I think we're going to take a similar approach where instead, and also I think what we'll do is this will equal 0, equal 1, equal 2, equal 3, by the way. And what we're going to do, can we have clone here and copy here? I'm not sure. Okay. 1 bit is assumed valid, but I actually don't know. Okay, instead of the flags, we're just going to do assume valid. I don't know. And for here, we're going to have something similar. Function. Well, all of these are public, by the way. Public mode pub flags. And this is going to have a U16. Okay. So now, okay, so what we're going to do, let mute value, which is going to be a 16, this. Now, 1 bit assume valid, bit 15. Now, if self.assume valid, value of this is going to equal 1, 15. Okay. So, 1 bit extended flag, bit 14, which it does say always 0 for version 2, which right now we're just going to be focusing on that. So 2-bit stage, bits 12 through 13. Now, value is going to equal, we're going to do self.stage as U16, and we're going to be 11, which I think we can do because we have assigned the different stuff. Can returning the local this consider, okay, we haven't actually finished this. Okay. Okay. Now we're going to have 12-bit name length, bits 0 through 11, and let name length equals self.path. Don't I have file path dot as os string dot length? No, length. So let field equals name length dot min of 0xFFF as U16. Then we're going to do value equals length field, and we'll return value. Okay. And the video is already probably going to be a bit long, so I think for now, what we're going to do is end up doing C times, will be C time, we'll do C time nanos, which will be C time nano, M time, which will be M times nano, which will be M times nano. We will do dev, which will be dev, no, which will be no, UID, which will be UID, GID, which will be GID. What do we have? File size, which will be meta dot, oh wait, we have that file size. And then we have file path, which is going to be path to path buff. This. The stage will be stage. Assume valid will be false. Missing object type. Okay. And object type, which will be object type. Okay, and now I have everything. So it should be pretty easy. And now all we'll have to do in here is when we have the index entry, we can just do from path. Okay. I think that's going to be it for this episode. I think next episode we're going to end up attempting to write the stuff and fill out some of the add and remove entry. I have some right here where I'm storing it in a hash map, although according to the documentation, we actually need it to be sorted. And so I think we might have some type of data structure that just sorts it upon entry, which I think is fine. That way we always maintain the order. And when we read it, we already know that it's going to be within the correct order. So yeah. Thank you for watching.